Good morning, everyone, and welcome to today's webinar, Is GRP Suitable for Hazardous Areas? My name is Tom Richardson. I can see some of you in the lobby already know who I am. For those who don't, I am the Business Development Manager for Southeast Asia here at Raytech. So let's get started. It's 9:01. I can see there's still some people filtering in. So in the webinar today, we're going to be looking at the different options available on the market in terms of luminaires, GRP or not GRP. We're going to delve into what GRP actually is, and then some design considerations for when it's suitable, when it's not, comparing modern fittings against bespoke fittings. Taking into consideration, installation, maintenance, and emergency performance. So what is GRP? GRP stands for glass reinforced polyester, where polyester is a type of plastic. So it is essentially plastic material which is reinforced with glass fiber. It's commonly known as fiberglass, but it does have small differences to what we would term as industrial fiberglass. We're going to take a quick look at the manufacturing process and how GRP is formed in its parts. So firstly, to manufacture the fibers, they use materials such as silica sand, clay, limestone, and other minerals. They're gradually melted in a furnace until they're liquefied. These fibers are then chopped and formed into mats of material and then can be used in molds to create a range of products. To do this, the molds are first treated with a special chemical mix, and then the first stranded mat layer is fitted into a mold and cured under high pressure and heat. This process is then continued with another layer of resin and a catalyst added after each new layer. This is then left to cure and another layer is placed on top. The shape is then made up with layers of pre-made fiber sheets. Typically, GRP will have a lower fiber content than what we would know as industrial fiberglass. So that is an overview of the manufacturing process. Linear design approaches. Generally, the design of different luminaires available on the market can be defined in the same way. You have GRP boat style fittings. So these are made from GRP, which are based on traditional fluorescent luminaires and use a GRP housing which is similar or often exactly the same as the existing fluorescent. Alternatively, a manufacturer may decide to design a linear luminaire from the ground up, not constrained to using the same design as an existing fluorescent, and they may choose to use a GRP housing for this. Or a third option is a bespoke linear using a metal housing. Typically, either stainless steel or aluminium are used for metal housings. We're going to look at the strengths and weaknesses of these options in more detail, but first we're going to focus on the choice of material used for the housing and why GRP may be unsuitable for certain applications. Now, of course, GRP does have its benefits and it's widely used for many reasons. It's lightweight, durable in the right conditions, and for a manufacturer is cost effective to mass produce. But when using in typical hazardous area applications, exposure to certain risks may mean that GRP is an unsuitable choice for a linear luminaire. Chemicals and solvents. So certain chemicals and solvents can react with GRP and could potentially cause the housing to become brittle, crack, or shatter. You may think this risk is restricted to only a few types of applications, but in reality, its effect can be much more widespread. Chemicals or solvents can be present in cleaning solutions, and any situations where the luminaires are exposed to oil are also at risk. For this reason, many offshore applications are also at risk, as the fittings can be exposed to drilling mud and cleaning solutions, which can then react with the GRP. Prolonged exposure to UV can cause the GRP to degrade over time and become brittle. In hot, sunny countries where the luminaires are installed outside, this presents another risk, causing the GRP to become brittle. This is likely to be a problem during the maintenance procedures, where the luminaire may need to be opened up or inspected, and any crack in the housing would invalidate the luminaire's X certification and render the fitting as useless. From our experience, we find in areas that there are a lot of sun and heat, when upgrades are required, the specification raised tend to be for more non-GRP fittings, so aluminium and stainless steel, with mentions sometimes to the UV stability of the luminaire. This is because previous issues they've experienced with things like cracked hinges after opening the luminaire during maintenance and relamping. The main reason for this is when GRP is exposed to chemicals or UV, it's always the parts that are under the highest stress that crack and fail first. Typically, this would be the hinges or other fixing points. Finally, GRP will usually be considered as less strong compared to aluminium or stainless steel luminaires in terms of twist and impact. There's also other parts of a luminaire's specification which you should check when comparing the luminaires. Number one is the temperature rating of the luminaire and its expected lifetime. Generally, these stats will be consistent across different styles of fittings and manufacturers, but given that GRP is considered to be a poor conductor of heat, meaning that heat is trapped inside the luminaire rather than dissipated out, it may be worth checking the spec, especially for high temperature applications, as a metal enclosure such as aluminium, which are likely to be a better conductor of heat, may be a better option. Certification restrictions. If there is an X on the certificate, this means that the luminaire can only be used in areas of low mechanical risk. So don't always look at the datasheet alone. You should always check the actual certificate for suitability to your specific application. And recycling. What will be the process of recycling the luminaire at the end of its lifetime, and what is your company's policy on recycling? GRP is difficult to recycle and reuse, whereas materials such as aluminium are far more renewable. Aluminium is one of the most recycled materials in modern day manufacturing, with over 90% recoverable. However, providing the environment suitable and there are no specific risks to using GRP, there isn't anything fundamentally wrong with using a luminaire with a GRP housing. It's therefore important to consider how the luminaire has been designed, or more specifically, how easy it is to install and maintain. These factors are the most valuable to an end user, regardless of the material used for the housing. We'll look at these factors in more detail across the main design approaches of luminaires. So, design considerations. In this section, we'll predominantly compare boat style LED luminaires with bespoke LED luminaires. Just to recap on exactly what we mean by a boat style luminaire, this is when the design has been carried forward, possibly for decades, based on an existing fluorescent design, but simply adapted to house modern LEDs. This is promoted by manufacturers as a cost-effective way to upgrade from fluorescent to LED. It will have a large polycarbonate front, with all the control gear housed within one large component behind the LED module. A lot of these design features are simply carried over from the fluorescent fittings and not necessary with LEDs, such as having a large polycarbonate window at the front, as LEDs are a directional light source. We're now going to compare the installation of modern LED boat and bespoke fittings. For the boat style, it's easy to replace as it's like for like, can be offered with an upgrade kit. So this is promoted as an easy and cost-effective solution. A competitor may promote this, but in reality, the cost for the upgrade kit can exceed the cost for a new fitting. If the luminaire is not being installed on a completely flat or level surface, or if they haven't been installed perfectly true with just a 1 or 2 degree offset, there could be some flex in the housing, may cause issues with water ingress if it causes the gasket to not seal properly. In contrast, a bespoke luminaire made from aluminium or steel should not suffer from these problems, as the housing will be rigid and the gaskets remain perfectly sealed. For a bespoke fitting, some manufacturers, including Raytec, have designed these fittings to be just as easy to retrofit as an existing boat style fitting, which we will touch on in the next slide. And as mentioned, this may sometimes be more cost effective than an upgrade kit. Now let's look at the retrofit options. In this case, we mean taking down an existing fitting and replacing it with a new fitting. Dimensions. Your replacement bespoke LED linear should be the same size as your existing GRP traditional luminaire. If the size is the same, then existing cables won't have to stretch any further, meaning there's no need to replace the cable. In terms of fixing centers, the luminaire should also have the same fixing centers as the existing GRP housing. Traditionally 3M6 and 3M8 fixing holes, and if these are located in the same position, have the same thread and depth as the fluorescent, then the same brackets can be used. Utilizing the same brackets on a job could have significant cost savings during the installation. Typically in offshore applications, the central fixing point of a linear are used for a retention bracket, which means providing the two-end fixing. Cable entries. Having the same size and quantity of cable entries will also mean the same glands can be used. Traditionally, there will be 2 M20 entries at each end to allow for through wiring or loop-in, loop-out setups. Combine these elements together and you have a replacement LED luminaire, which will reduce the time and cost of the installation compared to a product which hasn't been designed with these features in mind. A true retrofit solution. Just highlighting the fixing centers there on the slide. Maintenance. Boat fittings have one large compartment where all components are located. They're designed to be as familiar as possible to the fluorescent fittings, which people are used to, and so the ease of maintenance is restricted by the existing design. Fluorescent tubes no longer need to be replaced. More common maintenance procedure is now likely to be the luminaire's driver. A manufacturer of a bespoke luminaire has more flexibility in design, but not all will use this flexibility, and it will depend on the manufacturer. LED boat fittings with micro switches. Now this only isolates the lamp holders, but the main electronic circuit is still live. You must isolate the circuit if you are doing anything other than changing the tubes. For an LED linear, this therefore results in unnecessary costs and is of little value to the end user. GRP fittings are also often referred to as fish bowls in the field because of the large polycarbonate front, and these require a large gasket looking around 10 foot to seal the whole front of the luminaire. This is more susceptible to problems with water ingress and is more problematic when it comes to maintenance procedures and ensuring the gasket seals properly. The large polycarbonate front is unnecessary due to LEDs being a directional light source, unlike fluorescent tubes, meaning that a bespoke luminaire can be designed with less polycarbonate, meaning a smaller seal, and you can reduce the length of the gasket by about half to make maintenance easier. Here's a video to demonstrate how easy it is to replace a Spartan PSU. Power supply changed and powered up in 2 minutes there. So when emergency variants of your LED linear are required, it's important to look at the performance in emergency conditions in more detail. Output versus duration. Emergency performance is always a trade-off between how much light the luminaire gives off in emergency mode, usually as a percentage of the normal operating mode, and the duration, how long it will provide the light for when running off battery. The higher the output, higher the draw on the battery, and the shorter the duration. It all comes down to the size of the battery, and some manufacturers will fit smaller batteries to keep costs down and margins higher. This saving could come at the expense of the end user. Lower emergency output means if you specify a fitting with a lower emergency output, for example, 10% power, compared to a fitting with 25% power, it means one of two things. A, that more fittings will be required to hit the emergency light levels, which could add significant cost to the installation, or B, that the emergency light levels will be insufficient, which could provide a safety risk to those on site. Ratex standard intelligent emergency offering is 25% for 3 hours, but with the option of up to 100% light output. Modern LED fittings are also emerging, which build in more automation into the testing procedures. This is required as part of the hazardous area inspection procedures. Batteries can be cycled automatically to test the emergency functions are operating correctly and communicates the result via an LED indicator. Crucially, these systems should incorporate certain characteristics which we can see on the right-hand side of the slide. First of all, random. This is to ensure that multiple units don't enter testing at the same time. When they are testing, they should hold reserve battery capacity so that it still has power if energy drop occurs during testing. And the output, no noticeable drop in the level of light during testing procedures. It's important to give fair and balanced argument. In many applications, GRP luminaires may be perfectly adequate, but it's important to understand their limitations and the type of applications where they may be unsuitable. Use of GRP luminaires should be restricted from some applications, such as those exposed to high levels of UV or where chemicals and solvents are present. While it's important to consider the materials a linear luminaire uses, you should also look at the design of the luminaire. A well-designed luminaire will ensure optimum performance, easy installation, and running costs can be kept low by ensuring that it's easy to maintain. And lastly, always look more closely than a luminaire sales literature. Look at the X certificate to get a complete picture and ensure the luminaire will be suitable for purpose. So that's the content we've covered today. I'd like to take the time to thank everyone for their time and attention joining the webinar today. I will give a few minutes. You can type some questions if you have any. I'll answer a few of those and then we shall wrap up for today. Okay, so we have a couple of questions in. The first one, is there a list of chemicals which GRP cannot resist? So this is quite a situational question. Now, I don't have a list in front of me specifically of which chemicals a GRP fitting can be around and which may cause damage to it. It would depend more, it would be more accurate when discussing a site or a client-specific application to consider which specific chemicals are going to be on site, and then you can do research into the suitability and whether they come into contact with GRP. Second question, I was wondering if a GRP fitting would have any benefit over a more traditional style fitting in an offshore marine location. So for this question, you need to consider, of course, an offshore marine situation, but you need to consider things like, is the fitting going to be mounted in direct sunlight for prolonged periods? What sort of specific environment is it going to come in contact with? Oils, solvents, muds. You need to consider how the GRP is going to hold up against the saline environment, so the salt content of the water and air that it will come into contact with. The benefits that it may have over a more traditional style fitting, if it's a bespoke GRP fitting that has been designed from the ground up, you may get things like easier maintenance. But when you're looking at a marine application, you would want to consider something like marine grade aluminium, as that is going to be more durable and less at risk of failure than a GRP fitting would be. There is a question about whether Raytec as a manufacturer has installed on FPSO projects. As this is a CPD webinar, I will follow up with you directly after the webinar, as we try and keep these as removed from Raytec specifics as possible and just focus on more of the educational side. But thank you for the question. Another question here, what will be the predicted lifetime for LM6 marine grade aluminium in an offshore application, and what will it be for GRP? Again, quite a tricky and subjective question. So an offshore situation is going to have vastly different product lifespans depending on exactly where the unit is mounted. You could have one site where one fitting will never come into contact with any solvents, any oils, any muds, any chemicals. You may have a fitting on the same site that is constantly under threat of chemical attack. So again, it's taken into consideration the specific site and mounting points of each luminaire, what they are individually going to be exposed to, and what the risks for that specific site are. So unfortunately, it's very difficult to give you a satisfying answer to that question, I'm afraid. I'll give it another moment or two for any final questions to come through, and if there aren't any, we shall close up for today. Okay, then we've had no further questions asked, so I would like to thank everybody again for their time and attendance on the webinar. It will be uploaded to our website, so you can share it with colleagues, you can recap on any of the information we've covered today. And if you do have any further questions thinking back, you can get in touch with myself directly. My email address is tom.richardson@raytechled.com, and I'll be happy to help you out with any further questions you might have. So thanks again, and I'm going to end the webinar now.